Find the characteristics function of the following problems: d over dx of x dy over dx plus lambda upon x into y equals to 0, y1 equals to 0, y e raised to power pi equals to 0. Now solution: the given differential equation is d over dx of x dy over dx plus lambda upon x into y equals to 0. Equation 1, y1 equals to 0 and y e raised to power pi equals to 0. Equation 2, comparing one with the general Sturm-Liouville's equation, d over dx of px into dy over dx plus qx plus lambda rx into y equals to 0. We see that the equation 1 is a Sturm-Liouville problem. Now case 1, when lambda equals to 0. For the case when lambda equals to 0, the differential equation 1 reduces to d over dx of x dy over dx equals to 0. Equation 3, which implies x dy over dx equals to c1 by the integrating, which implies dy over dx equals to c1 upon x, which implies dy equals to c1 upon x dx. Integrating, we get yx equals to c1 log x plus c2. Therefore, the general solution of the equation 3 is yx equals to c1 log x plus c2. Equation 4, where c1 and c2 are the arbitrary constants. Applying the given condition to the solution of 4, on applying y1 equals to 0, we get y1 equals to c1 log 1 c2, which implies 0 equals to 0 plus c2, which implies 0 equals to c2. Therefore 4 reduces to yx equals to c1 log x. On applying the y e raised to power pi equals to 0, we get 0 equals to c1 log e raised to power pi, which implies c1 pi equals to 0, which implies c1 equals to 0. Thus, in this case, the solution of 4 takes the form yx equals to 0, which is a trivial solution. Therefore, for the case when the parameter lambda equals to 0, we get only the trivial solution of the given problem. Now case 2, when lambda not equals to 0. In this case, the equation 1 is d over dx x dy over dx plus lambda upon x into y equals to 0, or x d square y over dx square plus dy over dx plus lambda upon x into y equals to 0, or x square d square y over dx square plus x dy over dx plus lambda y equals to 0. Equation 5, for x not equals to 0, the equation 5 is equivalent to the Cauchy-Euler's equation, which can be solved as follows: letting x equals to e raised to power z. So dy over dx equals to dy over dz, dz over dx, which is equal to 1 upon x equals to dy over dz, or x dy over dz equals to dy over dz equals to theta y, where theta equals to d over dz. Similarly, x square dy over dx square equals to x square d over dx of dy over dx which is equal to x square d over dx of dy over dz, dz over dx, x square equals to x square d over dx of putting the value of dz over dx 1 upon x dy over dz equals to x square d over dz 1 upon x dy over dz, here dz over dx equals to x square 1 upon x d square y over dz square plus dy over dz into minus 1 upon x square into dz over dx into dz over dx. So x equals to x square 1 upon x d square y over dz square plus dy over dz into minus 1 upon x square into 1 upon x, which is equal to x square into 1 upon x square d square y over dz square plus x square into dy over dz into minus 1 upon x square into 1 upon x equals to d square y over dz square minus dy over dz. So equals to theta square y minus theta y equals to theta into theta minus 1 into y. Now putting the value of in the equation 5, we get theta into theta minus 1 y equal plus theta y plus lambda y equals to 0, or theta into theta minus 1 plus theta plus lambda into y equals to 0, or theta square minus theta plus lambda into y equals to 0, or theta square plus lambda into y equals to 0. Equation 6. Now sub case when lambda is less than 0, letting lambda equals to minus alpha square, alpha is greater than 0. Therefore the equation 6 becomes theta square minus alpha square into y equals to 0. The auxiliary equation is m square minus alpha square equals to 0, which implies m square equals to alpha square, which implies m equals to plus minus alpha. The general solution is y equals to a into e raised to power alpha z plus b into e raised to power minus alpha z, or y equals to a into x raised to power alpha plus b into x raised to power minus alpha, because x equals to e raised to power z. Equation 7. Now applying the condition to the solution of 7, on applying y1 equals to 0, we get y1 equals to 1a into 1 raised to power alpha plus b into 1 raised to power minus alpha, which implies 0 equals to a plus b, which implies b equals to minus a. On applying y equals to e raised to power pi equals to 0, we get y into e raised to power pi equals to a into e raised to power pi alpha plus b into e raised to power minus pi alpha, which implies 0 equals to a into e raised to power pi alpha minus a into e raised to power minus alpha, which is equals to 0 equals to a into e raised to power pi alpha minus e raised to power minus pi alpha. If a equals to 0, then b equals to minus a equals to 0. Therefore from the 7 we get y equals to 0, which is a trivial solution. Therefore for a is not equals to 0, or e raised to power pi alpha minus e raised to power minus pi alpha equals to 0, or e raised to power 2 pi alpha equals to 1 equals to e raised to power 0, or alpha equals to 0, which is a contradiction as alpha is greater than 0. Therefore we get no eigenvalue when lambda is less than 0. The subcase second when lambda is greater than 0. Now let lambda equals to alpha square, alpha is greater than 0. The equation 6 can be written as theta square plus alpha square into y equals to 0. Equation 8, where the auxiliary equation is m square plus alpha square equals to 0, which implies m square equals to minus alpha square equals to alpha square into iota square, which implies m equals to plus minus alpha iota. The general solution of the equation 8 is y equals to a sine alpha z plus b cos alpha z, or y equals to a sine alpha log of x plus b cos alpha log of x, because x equals to e raised to power z. Equation 9. We now applying the boundary conditions to the solution 9. On applying y1 equals to 0, we get y1 equals to a sine alpha log 1 plus b cos alpha log 1, which employs 0 equals to a sine 0 plus b plus cos 0, which employs 0 equals to b. Thus the solution 9 reduces to y equals to a sine alpha log x. Equation 10. On applying the y equals to e raised to pi equals to 0, we get y in e raised to power pi equals to a sine alpha log e raised to power pi. This is equation 10. Or 0 equals to a sine alpha raised to power alpha into pi, but a is not equals to 0, because if a equals to 0, then we get a trivial solution. Therefore sine of alpha pi equals to 0, or alpha pi equals to n pi, n belongs to n, or alpha equals to n. Therefore lambda equals to alpha square equals to n square, where small n belongs to capital N. Thus for the negative number is a meaningless, so we write the log of x as log of x. Thus lambda equals to n square, n belongs to n. The characteristics values and the corresponding characteristics function are y equals to cn sine n log of x, where n small n belongs to capital N, and cn are the arbitrary constants, hence the result.